All right, so thinking about learning target 1, we've got two big ideas. We're wondering about two things within the Milankovitch cycles, or the Earth-Sun relationship, right? And so there's changes that the Earth and Sun go through, one being tilt and one being orbit. And as those things change, more or less, or different shapes, we end up seeing an impact to the Earth's average temperatures and therefore climate. So each of these is broken up into two questions. One, what are the variations we can see? And two, what's that impact? Okay, so I think this one made more sense when I've been talking to students. This one people seem to be able to do first, and that will kind of lead us into the second one. So let's start here with Earth's orbit. Okay, we know that the orbit can change shape, right? It can change around, stretch between this elliptical shape and the oval, or excuse me, the circle shape. So we know, one, that's the first part, right? The changes that the orbit can go through, circle to ellipse and back. But what do we know about the impact then? So we're looking at how can the seasons be different because of those orbit shapes. So here in our circular orbit, we noticed in our diagram in our setup in class that distance the Earth is from the Sun as it goes around that circular orbit is pretty similar throughout the year, or really consistent, right? It doesn't have much change. It has a low variation, meaning that there's not much seasonal difference as the Earth is in this circular shape. When the Earth is in the elliptical or the oval shape, there's of course times where the Earth is far, times when the Earth is close. And so we called that having seasonal extremes, right? Seasonal extremes. So we're thinking about the close distances being warmer, the far distances being cooler, and allowing that ice, that Arctic ice, to really melt away during those warmer months. When we're more consistent in that circular orbit, that's the time we typically see the ice able to grow or stick around. Because of the consistency of the temperatures, it doesn't melt away, it retains or begins to grow. So again, back to the learning targets, we're talking about what are the different shapes and how does each shape impact the seasons. Same idea up here then with tilt. What are the variations of the tilt and how do they impact seasons or climate? So when we think about the tilt, it's a little harder because we don't have like a shape. We don't have a name for it, but we had our degrees. So when we think about the variations, we have times of more tilt and we have times of less tilt. There. Okay, more and less tilt. So more tilt, we're tilted more towards the sun, right? Here's our sun over here. That solar energy is able to hit those polar locations much easier than it is when there's less tilt. Less tilt, that solar energy, when it hits the Earth, can't fully reach the poles. And because it can't fully reach the poles with the lower tilt, that allows the ice to stay around or essentially grow. Those seasonal differences are less extreme because of the lower tilt. It's not tilted as much towards this light source. So the light can't reach as far north or south as it can when the tilt is much greater. When the tilt is greater or more of a tilt, it does reach the poles, melting the ice, causing those more extreme seasons, because when it's tilted towards, it's heating up. When it's tilted away, it's cooling down, and we're getting those high highs and low lows. So again, back to our learning targets, we want to list out what are our variations, right? Going from that 22.1 to 24.5, we have more and less tilt. And what do we notice about each one? Well, more tilt, what does that mean for seasons and ice? Less tilt, what does that mean for seasons and ice?